In a previous video, we talked about how in a Cartesian plane, vectors that are in the first quadrant behave a certain way or have components that behave a certain way in terms of their positive and negative x and y's. Vectors in the second quadrant behave differently than vectors in the third quadrant. Those behave differently than vectors in the fourth quadrant. What we're going to talk about in this video is vectors on a Cartesian plane. Now, I've inputted a little graph here. We'll see how this works. But if I was to draw, my grid here, we know that this is positive x and we know that this is positive y, right? So if I draw an actual vector, if I assume that I'm going to draw a vector on, if I draw a little graph over here, and I'm drawing this vector, well, this vector I've drawn in the first quadrant. Let's say I started back here at the origin. This vector is going to have a positive x and a positive y. Positive x because it's moving to the right, positive y because it's moving upward. But on a Cartesian plane, it's a little different. On a Cartesian plane, it doesn't matter where the vector is in terms of its quadrants. What you're looking at is the amount of grid lines or squares that the x and the y make up. So if I have a vector in the second quadrant here, if I've got a vector that leaves from the origin and points in this direction, that vector I know is going to have a negative x and a positive y. But if I draw this vector right here, even though it's in the first quadrant, it does not have a positive x. It has a negative x, because the negative x is starting from the tail of the vector and it's moving to the left in negative territory. It's going backwards, because positive x is in this direction, whereas it still does have a positive y. All right, so if we were to do this, if we look at vectors on a Cartesian plane, direction only matters, or behavior only matters when you're looking at the vector itself. On page 8 of your notes, you'll see that you have this exact same vector, all right, vector v, and it's placed on 3 different spots on the actual Cartesian plane. And in every one of those spots, it still has the same components. So when we're talking about vectors on a plane, a Cartesian plane like this, and you will get questions like this, you have to forget what the positive x, positive y, negative x, negative y behavior is, and you have to look at the direction of the arrows. So in this case, if we look at that image on page 8 of your notes, it doesn't matter where vector v appears on the actual Cartesian plane, its behavior is still going to be the same. Vector v is still going to have a vx component and a vy component. Those components, if we look at that actual graph, are positive 5 in the x and negative 3 in the y. When we get to adding vectors, we're going to see that these signs are very important. So we're going to move on to the next video on vector addition.